This is part 3 of our lesson on rational exponents. So what we're going to do, we just finished talking about rational exponents and what they do, and we discovered that a rational exponent, so that's a fractional exponent, that the numerator becomes just the regular exponent and the denominator becomes the part in the root. And you can either write the root on the inside with the exponent on the outside, or you can write the root on the outside with the exponent on the inside. So we're going to work our way through a couple of examples here. This says write each of the following as a radical. A radical is just another word for a root. And it says evaluate if possible. And that means that if I can work it out without getting a decimal, that's what we're going to do. So first things first, we've got 100,000 to the power of 1 over 5. So the 1 on the top is going to be my regular exponent, and the 5 on the bottom is going to be a root. So this is going to work out to be the 5th root of 100,000. And then we have a choice. We could put the power of 1 inside with the 100,000, or we could put this in brackets and put the 1 on the outside. Now this is how I prefer to write it, but it is correct either way. Now the 5th root of 100,000, unfortunately 100,000 is not on my power sheet because I don't have any powers of 10 on here. So you could use your calculator. Now this calculator here, we punch everything in as you see it. And to do a root, you use the second function of your exponent button. So I would do the 5th root of 100,000, we'd put in 5, and then second function or shift your exponent button, and then 100,000, which equals 10. So this is going to be 10 to the power of 1, and anything to the power of 1 is just itself, so this is going to be 10. Now the next one, I have 625 to the power of 3 over 4. So this, the number on the top is going to be our regular exponent. The number on the bottom is going to be our root. So this is the 4th root of 625 to the power of 3. I could put the 3 under the root with the 625, but I prefer to do it outside, and it doesn't really make a difference. So the 4th root of 625. I could use my calculator, but I am going to try using the sheet. What I'm going to do is we are trying to do a 4th root, so I want to look at the powers of 4 and see if I can find 625. So I have 16, 81, 256. There it is. 5 to the power of 4 is 625. So the 4th root of 625 is 5. And then that's still to the power of 3. And this sheet is actually very helpful because I can look up 5 to the power of 3, which is 125. The next number, we have negative 216 to the power of 4 over 3. So the number on top is my exponent. The one underneath is going to be a root. So this is going to be the cube root, or the 3rd root of negative 216, all to the power of 4. So normally we've always learned that you cannot take the square root of a negative number. And that's true for any even numbered root. So square root, 4th root, 6th root, 8th root. But if it's an odd number here, it is possible to do the root of a negative number. So I'm going to try it on my calculator, and then we will take a look at how to do it on the sheet. So if I do the 3rd root of negative 216, you'll notice I get an answer of negative 6. I can also look at the sheet and look for a power of 3 that gives me 216, and you'll notice that 6 to the 3 is 216. So this is going to be negative 6 to the power of 4, and I could use my calculator, but I'd rather use the sheet. 6 to the power of 4 is 1,296. And if the exponent is an even number like 2, 4, 6, 8, 10, then my final answer should be positive because all the negatives are evenly paired off. If this was an odd number, I would end up with a negative in front of this number here. Okay, and if we want, we can actually check. If I do bracket -6, close bracket, to the power of 4, you'll notice that I do get positive 1,296. All right, the next one has not just a rational exponent, but a negative exponent. So 64 to the -5/6. First thing I'm going to do before I do the root is I'm going to deal with the negative exponent. And if you remember from the other lesson the previous day, a negative exponent makes a fraction. It has a flipping over action. So that 64 is going to become 1/64, all to the power of 5/6. So I didn't flip the exponent. You never flip the exponent. I only flipped the base because that's what a negative exponent does. And then I'm going to deal with the root. So this is going to be the 6th root of 1/64 to the power of 5. Now, if you try typing that in your calculator all at once, you're probably going to get a decimal. So I'm going to do it in pieces. So we're going to do the 6th root of 1 and then the 6th root of 64. So the 6th root of 1, you'll notice that 1 is not a power on my sheet, but really 1 times 1 times 1 times 1 times 1 equals 1. So the 6th root of 1 is just 1. Now the 6th root of 64, I'm going to take a look on my power sheet at the powers of 6, and I see that 2 to the power of 6 is 64, which means that this is going to be 2. The 6th root of 64 is 2, and then this is to the power of 5. And then to figure this out to the power of 5, we do 1 to the power of 5, which is 5. No, it's not. It's 1. Sorry about that. And 2 to the power of 5, I can use my sheet, or you can use your calculator, but 2 to the power of 5 is 32. Ooh, the next one is a fraction with a fractional exponent. So the fractional exponent is still going to be a square root with a power of 3, and the root's just going to go over this entire thing. So this is going to be the square root. You can put the 2 in, you don't have to put the 2 in, it's up to you, of 16/25, all to the power of 3. And to evaluate that, I would do the square root of 16. So 4 squared is 16, so that's 4. And then the square root of 25, 5 times 5, or 5 squared is 25, so that's going to be a 5. And this is still to the power of 3. You'll notice that I'm doing a bracket here to show that that power of 3 is on both the numerator and the denominator. And then I need to evaluate 4 to the power of 3. You could use your calculator, or 4 to the power of 3 according to my sheet is 64. And 5 to the power of 3 according to my sheet is 125. Now the last one has a fractional base, a fractional exponent, and a negative exponent. So the first thing I'm going to do is deal with the negative. So the negative exponent makes a fraction. It has a flipping over action. So what it's going to do is flip over my base and make it 2,401 over 6,561. It does not flip the exponent, but it does, however, make it positive when I do the flipping. All right, and then I'm going to write this as a root. This is going to be the 4th root of 2,401 divided by 6,561, all to the power of 1. Now the 4th root of 2,401, I could use my calculator, but I'm going to look on here at the powers of 4, and I notice that 7 to the power of 4 is 2,401, so that's going to be 7. And 6,561, I notice, is 9 to the power of 4, so this is going to be 9. All to the power of 1. 7 to the power of 1 is 7. 9 to the power of 1 is 9. Now we do have two more questions here to look at, and it says write each of the following in exponential form. So this is actually going backwards. Instead of giving me an exponent and having me write it as a root, we're going to take the root and write it as an exponent. So there's two ways that you can do this. The first one is I have x to the 5 to the power of 3. So I already have the exponent of 5. I just need to figure out where that 3 fits in. And the root part is always the denominator. So this would be x to the power of 5 over 3. Now the other way that you could do this question is to treat them as two separate things. So you could say I have x to the power of 5. And then that is being square rooted. And a square root would mean a denominator of 3. Sorry, a cube root would be a denominator of 3. And if there's nothing else, then just an exponent of 1. And then if you multiply these together, 5 times 1, or 5 times 1/3, is x to the power of 5 over 3. So this method is sometimes helpful on things like the next question where you have multiple steps. But this one is usually the one that I like to use the most, where I just try to write it with the exponent and the root all at once. So this last question here, we've got the cube root of the fourth root of x to the 7 all to the power of 5. And I'm going to start on the inside and see if I can work my way outside. So x to the 7, the fourth root of x to the 7 would be x to the power of 7 over 4. And that's still in a cube root, and that's still to the power of 5. Now, a cube root to the power of 5 would be the same thing as saying that it's to the power of 5 over 3, right? So I treated these ones together. And then our rule here, when we have brackets, is we just multiply. So 7 over 4 times 5 over 3, we do numerator times numerator. 7 times 5 is 35, and 4 times 3 is 12. So I get x to the 35 over 12. And that's it for now.